Everyone, we will solve this today's LeetCode problem. This is again a LeetCode easy one. So let's see what the question is. It's a relative short array. So we have given in two arrays, array 1 and array 2. The elements of array 2 are distinct and all elements in array 2 are also in array 1. Sort the elements of array 1 such that the relative ordering of items in array 1 are the same as in array 2, and elements that do not appear in array 2 should be placed at the end of array 1 in ascending order. The question is asking to maintain an order of this array 1 elements according to the array 2 elements, right? So here we have given this order of array 2 elements. If the elements which are present in the order of the array 2 should be rearranged in array 1 also, and if the elements that do not appear in array 2, suppose in this example, like 17 is not present in array 2, right? In the second example, so 17 should be placed at end of array 1. So the how many elements are not present? 17 not present, 14 4 not, 44 not present. So these two elements are not present at the in the elements of array 2. So this should be placed at last but in ascending order. So that's why it's placed as 17 and 44, right? Understood the questions, right? Okay. So we need to maintain the order according to the array 2 elements. So for that, the basic thing is the basic the basic logic is to we need to know. Basic logic is that we need to know, right? We need to note the elements of array 2 simply, right? We If we don't know the elements of array 2, how we will rearrange this order of array 1, right? Simply we need to know the elements of array 2. Okay. So for that, what we can do, so we need to see that which elements are the common elements between this array 1 and this array 2, right? Suppose this 2 is occurring, so we will see that at which places are the 2 is occurring, how many times this 2 occurs. So it occurs one time, two time, three times, right? So we will just store this 2 in other, right? We will just store simply. If there are two times occurring, then we will just store it, right? So for that, what I can do is, if I see this first example, this 2 1 4 3 9 6, so we will just simply count the number of elements of each distinct element, the number of each distinct elements present in array 1. We will store that count. How we will store? For storing, either you can take either you can take either you can take a hash map or an array. Why we can take an array? If you see the constraints here, that array 1, the elements can be from 0 to 1000. So we can simply make 1000 elements, right? So we can take 1000 elements. We can almost store 1000 elements in array. So yeah, either you can take a hash map or an array for counting purpose, for counting the occurrences of elements present in array, right? Right, we can count. Okay, let's count it, right? Let's count it. If we count starting from 2, 2 is present how many times? 1 to 3 times. 3 present how many times? 1 to 2 times. 1 is present one time. 4 is present one time again. 6 is present one time. 9 is present one time. 19 is present one time, right? So 3 to 5, 6, 7, 8, 9, 10. 2 and to 4, 6, 8, 10. One number is missing, 7. Right, 7 is missing. 7 is missing, right? So we stored all the counts in HashMap or a counting array, right? Now what we need to do, we will iterate in this array 2 and check which elements are present in my counting array simply, right? Which elements are present in my hash map, like 2 3 1. So if it is present, we will just store this number of times it is occurring in array 1 in my answer simply, right? So what I will check, I will move to this elements 2 1 4 3 6. This, the first thing is here 2 4 3 9 6, right? So this need to be stopped, and yeah, This 2 is present. Yes, this 2 is present. So what we will do, we will store 2. How many times? 3 times. 2, 2, 2. Right? Now this 1 is present. Yes, 1 is present. How many times? 1 times. We will store that. How many times 4 is present? 1 times. We will store that. How many times 3 is present? We will store that 3 times, 2 times. How many times 9 is present? 1 time. We will store that again. Now 6, for 6, how many numbers, how many times it's present? 1 time, right? We will store that. So this ordering is completed. But if you see, we have still left some elements. Which elements are there? The 7, 19, right? 7, 19 are present, right? So for the 7, 19, what I need to do, I need to store them separately. Why? Because here you see that we need to place it in ascending order. So for that, for placing this in ascending order, we need to make the we need to sort it. These are the number extra. These are the extra elements. These are the extra elements present in where? Present in array one, right? Present in array one. So we need to we need to arrange them in ascending order. So for rearranging, either I can short it, we can short it simply we can simply short it. After sorting, we will just put this at last. Simple. So if you see, this will be our answer. 22143 396 719. Here is the answer. So what we are simply doing, we are we are simply doing that we are storing the count of all the distinct elements present in array 1, and and again iterating in the array 2 for checking that which element is present in array 1, and if it is present, then what we are doing, we are just storing, maintaining that order. We will we will store we will rearrange we will rearrange the numbers according to that, right? And what if the numbers are extra in array 1, right? And if you see the numbers in array 2, the numbers in array 2 is, the constants are given that each array 2 I is in array 1. It means there will be never be that number present in array 2 that is not there will be no any cases that array 1 has some elements and array 2 doesn't have, right? Opposite can be true, but there can be not any element that array 1 is present and array 2 is not, in array 2 is not present. So here we have written that each array 2 I is in array 1. So if suppose there can be not cannot be a case that where the element in array 2, there can be not be any case, there will be no any case where an extra element present in array 2 which is not present in array 1, right? There will be no any case, right? So the third case is that if the extra elements are present in array 1, right? So in that case, we will we will put them at the end after in increasing order, right? Increasing order. So for that, what we can do, we can short it short the extra elements only. We can short the extra elements simply. So this approach would be used by us right? So let's see what we are doing. So the first thing is, we need to store store all the occurrences of distinct elements present in array 1. So for that, I will use a hash map, or you can tell hash table, or we will store all the elements of array1 in my hash map simply, right? So I will store all that. I've stored all that. Now I will check for each element present in array2 for maintaining the order, right? Okay, we will just check each for every each and every element, that whether it is present in my hash map or not, right? So for that I will check that whether it is present or not. If it is present, it means I will just insert in my answer. So for that, what I will do, I will take an answer, right? I will take an answer. Now again, the one thing is, this answer should be included. So how many times it can be present? So it will be, so the count will be, we will check that whether it is present or not. So if it is present in my map, it means it occurs in array 1. Now how many times you need to present? So it should be present mp val, right? So instead of checking, what can I write like this? Mp of val, mp dot count val, and mp of val minus minus. Can I write like this? Yes, I can write like this, right? Simply, right? So what I will do, I will just store the times it present in array one in my answer, right? Right. The times it present in my val it in my answer, right? Simply, and it can be also there, that some elements in array one is not present in array two, right? Some of the elements can be there, right? So for that, what we can do, we can simply store that. How we will check that? So for that, what I will do, I will iterate again. We will iterate again in this map, this map, and we will check that which elements are not zero, which elements are not zero. Because when we are doing mp val minus minus, what does it mean? It means it, when it will be, and when this will become zero, right? So we will check if mp of it dot first is equals to is not equals to zero. It means it does not occur in array 2, right? So what we will do, we will store this in another vector, right? In another vector, which will be dot pushback in it dot first, simply, right? This we will store that. And after that, again, what we need to do, we need to, this is an extra elements, so we need to short it, we need to short it in ascending order. So we will just sort it and append it, means we will push back, uh, we will push this in end of this answer. So for that, I need to just call this, call call this, and we just need to store how many times, the times it present in map, the times it present in map, because we are storing only one distinct element, but it can be present multiple times. So we will store it multiple times in answer. Okay, we will store multiple times in answer, and at last I will return the answer simply. So if you see what we are doing, we are first storing all the counts, then we are moving in array 2 types, array 2 ordering, and checking that whether this is present, and if it is present, we will store all the number of occurrences in my answer. And also we need to check that whether any extra elements is present or not. If it is present, so how we will check? Because after this, the numbers which are occurs in array 2 should be count 0, because we have already pushed that. So the remaining elements which is not equal to 0 should be pushed in the remaining, and we will sort that. And again we will just push it at last, the total occurrences, and just return the answer. Let's try to run this. Let's see what if this is giving any compilation error or not. Hmm, I think it's giving TLE, right? Why it is given TLE? Let's see the while loop. I think something is missing here. While loop, MP val array to I. This should be correct, I think, and this should be also correct. Okay, if the elements are not present, so instead of this, let's try to just use this MP of IT minus minus and MP of L minus minus. Now I think this should work. Let's see. Yeah, it's working. The problem is when you do MP minus minus. So if this MP of val is zero, if MP of val is zero, and if does the minus minus, it becomes minus one, right? It becomes minus one. So it does not. It will not get. It will not break in this, right? When we do MP value minus minus. So instead of this, it's easy. Easy to write like this amplifier, and later on decrease it when we store it, right? So that's why it is giving TLE, because it can be possible that this value is not present in map. So this it can be possible, right? It can be possible. It's it dot first is this mp dot it is less than is equals to zero, and when we do mp it minus minus, so it never be ended. It become all negative and negative, minus one, minus two, minus three, minus four, right? That is the reason we just store mp of it, and later on we are decreasing it. That's the reason of TLE. Let's just submit it, and I hope there will be no any mistake on each cases left. Yeah, we have just passed all the test cases. Now the main part is time of complexity, which seems to be confusing. Let's analyze this, but it's not, believe me. uh, the first thing is we are iterating in all the array of 1 for storing, so that would be O of n, right? That would be O of n. Simple. The second thing, we are moving in whole of array 2, that, and each for each elements we are counting, we are moving again in all the direction for each elements. So do you think that this will be O of m into n? No, it will be not m into n, because if suppose this 2 is present, the first element is 2, so how many times this while loop will run? This two, the number of occurrences of 2, which is 3 only, right? So the first element 2, it is occurring 3 times, right? The second element's 1, it is again occurring only one time. The third element 4, it is occurring only one time, right? So you see this while loop, how many times this while loop occurs. Don't see like that for each elements we are using while loop. No, you see that how many times this while loop occurs. This will run only O of n times, which is the array 1 length. This will run only O of n times. No, overall times, overall run, how many times this while will occur. This will O of n times only, right? And if this is occurring only O of m, so it will be O of m, and this is O of n overall, right? This is not om into n, this is O of n overall, and this is O of m only. So this you see O of m and plus O of n, O of m plus O of n, and this will also not O of this will also O of n, and this will O of m, and this will be also not O of n. Ultimately, in the worst case, it can be O of n, because some elements also not be present in this array too, right? Some elements can also be not present, but in the worst case, it can be O of n, but it will be already less than O of n, right? So that is the O of m plus n. Now again, for storing the remaining elements, we need to iterate in this m. So we are iterating in the distinct elements, right? We are storing in the distinct elements. So you can take this as O of k, which will be always less than, very much less than this O of n, very much less than O of n, right? So this is the something, and the remaining elements is sorted, so that can be in the worst case will be O of n log n, because it can be possible that array 1 has all the elements short in distinct elements, so that will be O of n log n and log n, right? That can be O of n log n. Now again, we see that we need to iterate in all the remaining elements and push back it in it. Again, this is occurring only the occurrences of time, right? So again you can check that O of it will be ultimately O of n. So over time complexity, if you see this O of n, O of m plus n, O of k, O of n log n, this k can be at most n, right? And log n and O of n. So it will be, if you see, this can be possible that this will be O of m simply plus the bigger elements. The n log n is bigger here, from O of n, O of n, O of n, 3 times O of n and this n log n. So O of n log n is bigger. So O of n log n. So this is the overall type complexity of this problem. And the space complexity, it is the simple, right? It's simple. The space complexity would be unordered map for storing all the distinct elements, so that will be overall O of n. Again we need an answer and the remaining for storing that to total answer and the remaining elements, so that will be again you can take O of n, O of n for unordered map again plus O of n for storing answer. And in the worst case, that all the elements which are present in array 2 and also not present in array 1, that will be an extra elements, so that will again take O of n. So over time complexity would, space complexity would be O of n, right? So that's the time and the space complexity would be here, right? So we can also use this inbuilt, we can also use this already given array 1 or array 1, but that's no need, because it doesn't affect much in space complexity, because one on will be removed only, so that much is not affected. Or you can use, if you have if you want, because this array 1 is the same size of answer, so you can use the array 1 in place algorithm. So yeah, I think this would be okay. So we are using a map instead of that. instead of map instead of map instead of hash map, instead of uh, instead of hash map, you can also use array. So which is the same as this, just that called a counting short, right? If you use an array, that we called a counting short, right? So it's the same process. Instead of this map, you use an array of the size, the maximum element present in array 1, right? Or which can be further go moved to at most 1,000. So it's the same process, right? So either you can use a map or you can also use an array. That's the same process. Hope you understand. Thank you so much. Bye bye. Bye bye.